Plastics are developed by chemists to have different properties that make them useful in different situations. For example, PVA or polyvinyl acetate is soluble and is used as adhesive. You may recognize it as a glue used in schools, but it's also used for wrapping laundry and dishwasher detergents because it will dissolve in water. Sodium polyacrylate absorbs water, unlike most other plastics that repel water, so it's often called hydrogel. This makes it useful in disposable nappies, and they have also been developed to change colour when wet. It's not essential that these plastics and their uses be memorised, but it is good to be aware of the different types of plastics that exist and how they've been developed to have certain properties. All plastics are polymers. You may have noticed the prefix poly in a lot of the previous plastic examples, but we'll talk about naming later on. A polymer is a molecule made from many small units joined together. These small units are called monomers. Synthetic polymers are made from crude oil products, and examples of them are polyester, polystyrene, polyethylene, etc. These are cheap to make and are easily mass-produced, but most of them can't be recycled and they produce toxic gases when they're burnt. Bioplastics are renewable and recyclable, though they are harder to produce. Natural polymers are produced by living things, and examples include starch and proteins. Polymers fall into one of two categories: addition polymers or condensation polymers. Addition polymers are made from many small unsaturated molecules. Condensation polymers are made from monomers with two or more reactive groups and produce a small molecule in addition to the polymer when they join together. Condensation polymers are not covered at this level, but it's good to be aware of the other type. We're going to be focusing on addition polymers for the rest of the lesson. Addition polymers can be easily identified from their bar backbones because they contain only carbon.